so I'll be talking about the physiology of hormones. So just to give you an overview, a hormone is a chemical messenger, and what it does is that it delivers a message from one cell to another. Simple. Now, for the types of intercellular communication, there are different modalities through which the message is transferred. The first being the autocrine signaling, where auto means self, and so it's where a cell targets its own. Then we have the paracrine signaling, where para means next to, and this modality involves cell signaling a nearby cell. Endocrine signaling, on the other hand, is where a cell targets a cell that's far away through blood as a method of transportation. And finally, we have direct signaling, where a cell targets a neighboring cell using these gap junctions. Now for the endocrine glands. Okay, the first one being the hypothalamus, which is a part of the CNS, but it also produces hormones that influence the pituitary gland. Then, a quick tip to remember the hormones of the hypothalamus is that all of them either contain the word releasing or inhibiting, which means like they have the letter R and I in their names. So we have thyroid releasing hormone, corticotropin releasing hormone, gonadotropin releasing hormone, growth hormone releasing hormone, and growth hormone inhibiting hormone. Now moving on to the pituitary, and actually this is named the master gland, and because it controls the action of many other endocrine glands. The anterior pituitary is basically influenced by the hormones of the hypothalamus. The thyroid stimulating hormone is what stimulates both T3 and T4, which are triiodothyronine and thyroxine hormone. And these are usually secreted from the thyroid and are responsible for regulating the body's temperature, metabolism, and heart rate. Now, we also have adrenocorticotropin hormone, and what it does is that it basically stimulates cortisol secretion, and this cortisol is the primary stress hormone, which basically increases the glucose in the bloodstream in order to help the individual fight or flee a stressor. Then we have the growth hormone, which, the name explains itself. It basically acts on the body tissues to control growth. Then we have the follicular stimulating hormone, and this follicle stimulating hormone basically stimulates follicle growth in females and sperm production in males. We also have luteinizing hormone, which this here, you can remember its function by the fact that it starts with an L, and ovulation, the word ovulation has an L in it. So yes, keep in mind that the luteinizing hormone is always associated with ovulation. So a surge of LH equals ovulation. Keep that in mind. LH equals ovulation, and that will be especially important when you take the reproductive system. Now for the final hormone produced by the anterior pituitary, which is prolactin. And what it does is that it produces milk, and it also is involved in breast development. Now moving on to the posterior pituitary hormones, and it releases two hormones, the ADH or the antidiuretic hormone. And what this hormone does is that it causes the kidneys to release less water, decreasing the amount of urine produced. So it's basically anti-peeing. Now the second hormone produced by the posterior pituitary is the oxytocin. And this acts or causes both uterine contractions and milk ejection. Now, you might ask yourself, well, didn't you just mention milk and prolactin? Well, the difference is that prolactin produces milk, so prolactin produces milk, while oxytocin ejects the milk. Okay, so now for the thyroid gland, it releases both T3 and T4, which we've already mentioned, and they regulate the metabolism, heart rate, and temperature, body temperature. And there's an additional hormone, which is calcitonin, and you might be tricked by the fact that it has the word calci in it. So you'd think, oh, that increases the level of calcium in the blood, but no. It actually decreases the blood calcium levels. And finally, we have the parathyroid gland, which releases parathyroid hormone. And basically, it has the opposite function of calcitonin. So it basically increases the levels of calcium by releasing calcium from the bones and stimulating vitamin D activation.